Okay, we're going to look at some section 10.1b, simplifying radicals. Here's the first example. The square root of 12x squared y to the fourth. Simplify the following expression and assume that the variable may be positive or negative. Okay, so what we need to do basically is look at the factors that we have underneath. Okay, what's underneath here is called the radicand. You learned in the last section that square root, whatever root you're talking about, you're thinking what number times itself gives me what's underneath. With the simplifying part, you're looking for, in this case, pairs of factors that are identical. For any pair of factor that's identical, you should be able to square root it. So what I'm going to do is I'm going to show you in the tutor mode. I actually noticed the tutor mode's a little bit a little bit annoying to me in this section, but if you just press solution, they break it down pretty nicely for you to just kind of see what happened. Because what they do is they take 12 times x to the 12th y to the fourth square rooted. They take that part underneath there and they say 12 is 2 squared times 3. So they made a little factor tree. 2 was a repeated factor. And then they had x to the 12th, y to the 4th already. And they say just take each type that you have there and square root each of those individual pieces. So square rooting factors individually is the same as square rooting the whole thing. And then you look at each piece and you say, okay, can I square root anything that I have there? So 2 squared square rooted just gives you 2. They jumped around the order here a little bit. X to the 12th square rooted, you basically take half the power if it's a square root. If this were a cube root, you'd divide by 3. So whatever you've got there, I can just, in this case, take half the power. That's where the x to the 6th comes from. Half the power here is y squared, so it's really taking the square root of all of those. And then the cube root of, the square root of 3 stays as the square root of 3 because there's only one factor there. If you had a repeat, you could take a look at it, but that's as far as you can go with that piece. Okay, so that's kind of the idea, and we can take a lot of these examples and think about them that way. The square root of 36 y to the 6th. If we go to tutor mode, look at solution, you'll notice that they take each value, they square root the first value and the last value. A step that they didn't do, that they probably should have, is to show you that 36 is the same as 2 times 2 times 3 times 3. That's where they get the 2 squared and the 3 squared from. So that's kind of a mysterious step there. But the 36, you could also just say the square root of 36 is 6. Okay, that would be reasonable as well. But let's notice the rest of the stuff that they did here. They said the square root of y to the 6th, and then they have that down here as well. And then they give you the absolute value of y to the 3rd. Now the weird thing about the absolute value part, you may look at that and be like, where did that come from? Okay, it's just the idea that if they say assume the variable is positive or negative, that means that it could have been a negative value there. And the only way that's really going to even matter in these types of problems are when you try to take an even root, okay, so a square root, a fourth root, or whatever, and then you have an odd result, okay? If they said assume the variable is positive, we don't have to worry about any of this absolute value stuff, I guess, anyway, because it would just be positive and we'd know it. But the idea that I have a y cubed here, if y ended up being negative, it would be a negative times a negative times a negative, or an odd power would give you a negative result. But we're assuming that it's positive based on the fact that it was raised to an even power and then proper square rooted. So as a little rule to yourself, you can just kind of say, in your answer, if you end up simplifying a piece by taking an even root, and your answer for the variable is an odd power, you're going to need that absolute value symbol. Okay. Also assuming that variables could be negative. Just a weird little case to look out for. Okay, maybe we'll encounter that again. This example, it says simplify the following expression and rationalize the denominator. So we're going to simplify, and with a fraction, we can take the same radical of the top and the bottom as the whole fraction. So if I have a square root of a fraction, what I have is the square root of the top and the square root of bottom, and then doing that out, basically I would end up with, and just like some of the other examples, halving the power. Okay, we've got an even power and an even root, so we just could say x squared, even root here, square root, and then looking at what's underneath, the square root of 81 is 9. The square root of y to the fourth, half that power, is y squared, and you'd be done. Okay, so just kind of keep cruising through these examples, see if they make sense. We've got a cube root problem here. The cube root of 54x to the 8th. Now right off, we don't have to worry about that whole example with the absolute values or anything like that, because we've got an odd root going on. So don't even fuss with that. Now we're looking at 54. What can I say about 54? You know, I'm not quite sure if that's going to come out nicely or not, if it's a perfect cube. So checking out what they do in the solution set, they take 54, they break it down as 2 times 3 to the third, which again, if you don't know how to do that, you're just making a factor tree. 54 is 27 times 2, you kind of branch down from it. 9 times 3 is 27, 3 times 3 is 9. You'd end up with 3 3's and a 2. X to the 8th, they left it written that way, and then they just cube root each piece. And when you look, this weird result here, I'll tell you how they get this. Cube root of 2, there's nothing I can do with that. There's only 1 2. So that's going to end up still underneath the cube root symbol. The cube root of 3 to the third, I've got 3 3's. When I cube root that, it's always just what's underneath. So that's out front just as a 3. Now the rest of this, there's an x squared out front and there's an x squared underneath. How did that happen? Well, what happens is basically like having, it's almost like dividing and having a remainder is the way I think of it. 3 divides into 8 and it goes in twice with a remainder of 2. So however many times it goes in, it's basically telling you what's going to be outside here, x squared. There's a remainder of 2, that's how much is going to remain underneath. So that kind of breaks things down fairly nicely, but it's really that you have a couple of x squareds and then what's underneath. Alright, hopefully that helps a little bit, and we'll go from there.